to solve using my simultaneous equations. What's the third thing that I know? T3 is 23. Now, I actually know way more than that, and I could find more if I wanted to, but I only need 3 equations, 3 things missing. So anywhere I have an n, I can now put in a 3. That's 9a plus 3b plus c equals 23. Here's my third one. Off I go now and use my algebra. I'm going to try and get rid of c's first. So I'll take this equation and this equation. I'm going to multiply this one by a -1 and hopefully solve to make it a little bit smaller anyway, to make it look like more like a junior cert one. A plus b plus c is equal to 12 and 4a. So minus 4a minus 2b minus c equals minus 16. They're gone, which is what I want. That gives me minus 3a minus b equals minus 4. So there's my junior cert one. I'm going to do the same. I'm going to take these two and I'm going to also leave this one multiplied by a -1. So I have 9a plus 3b plus c equals 23, and I'm going to leave that one as a minus 4a minus 2b minus c equals minus 16. That gives me 5a plus b, they're gone, which is what I wanted, and that gives me 7. There's my second one. Looks like my b's are going to cancel there nicely. So that's 5a plus b equals 7 and minus 3a minus b equals minus 4. And so I have 2a equals 3, a equals 1.5. If a equals 1.5, I can go back and solve whichever one of these that might be most, or the easiest to do. So I'll take this one here, 5 times a plus b equals 7. So 5 times 1.5, should be able to do that, 6.5 I think. Oh, nope, 7.5. I don't know why I said that. Plus b equals 7, so b is equal to minus 0.5. So a is that, e is that, and c I can get by going back to the start. A plus b plus c is equal to 12. So 1.5 plus a minus 0.5 plus c equals 12. So that gives me 1 plus c equals 12. C is equal to 11. So what does my term look like now? Paper. It now looks like a n squared plus bn plus c. That's what my general term now looks like. And you can check that out and see, does it work, you know, if you put in 1. So 1 squared times 1.5 minus 1.5 plus 11, that definitely works. That gives me the first term, which is 12. And so on. You can check, does it work? And it allows me now to be able to find the 5th term really fast if I didn't have it. The 10th term, the 20th term, the 100th term, I don't have to get them all the way up along. If I give you this sequence, okay, so that's that done, being able to find the general term. If I give you this sequence, the 12, the 16, the 23, 33 and 46, and asked you to sum up the first 10 terms of this sequence, you'd have to obviously find the next 5 using either this if you had it, or you could just work it out. Take your time and work out the next 5 terms. If they wanted you to sum up the sequence, there is no fast way to do it. So for a linear, if you wanted to sum up the sequence, You can type it in bit by bit into your calculator, or obviously if it's a longer one, you go to your log tables, get your summing up formula and fill it in. If it was geometric, you do the same thing. You go to your log tables if you want to and get your formula and fill it in. But for a quadratic, there is no fast way to sum it up. Tough. You just have to type it in bit by bit into your calculator and add it up. You can stop the video if you want now, because that's all that you technically need to know. But if you want to, you can just get here a helpful hint. It'll speed up getting the general term. If we go back to here, same example, you figured out that it's definitely quadratic, and you decide that I need to get the general term of it for whatever reason in the question. If you did enough of these, you would actually see that the coefficient of the n squared is always half of this. It's always half of whatever your second common difference is. So in this situation, you'd notice that 3 is my second common difference. And if I halve it, it's the coefficient of the n squared. So when you do it like that, so if you halve your common second difference, you can always know that that's going to be the coefficient of the n squared. Now, how is that helpful? Well, it's straight away, you don't have 3 things missing. You don't have a long leave insert simultaneous equation to do. You'd know that this is 1.5. You can move it around, bring it over here, and you'd have